Good morning, everyone. My name is Abhishek Chaudhary, and today I'll be presenting on troubleshooting KML parsing issues in Liquid Galaxy. Before I begin with the technical part, I want to give a little background on about why I chose this topic. So, while working with Liquid Galaxy systems, especially while building applications on top of it, I noticed that many times when something fails, the problem is not in the application logic, not in networking, not even in the controller, but simply in the KML file that is being sent to the Google Earth. The difficult part is that the KML fails, the system usually does not give a clear error message. The system may stay blank or show old content or behave in unexpected ways. So, debugging becomes more about understanding how the system works internally rather than fixing syntax errors. In this presentation, my goal is not only to list common problems but to explain internal workflow of Liquid Galaxy, how the KML flows through the system, and how we can build a structured mental model for debugging. First, I'll explain what role KML plays in Liquid Galaxy and then how the system loads and refreshes the files. After that, I'll discuss some common parsing and generation issues. And finally, I'll talk about advanced cases like tours and orbits. By the end, you should not only know what errors might happen, but also why they happen and how to approach them. So let me start by explaining what KML actually means in context of Liquid Galaxy. KML or Keyhole Markup Language is the foundational format used by Liquid Galaxy to render all visual context of Google Earth. Which what this means is that Liquid Galaxy itself does not draw graphics on the screen. Instead, it sends instructions to Google Earth in form of KML files, and Google Earth in response renders everything that we see. Every single element on Liquid Galaxy display, whether it's a logo, place mark, information balloon, an orbit, a tour, or even a screen overlay, is completely driven by instructions written inside a KML file. This practice KML acts as a communication layer between our application and visualization system. Now, one very important characteristic of Liquid Galaxy is that it continuously reads and parses these KML files in real time. This means that system is not loading the file only once, instead it keeps monitoring the file, and every time the file changes, Google Earth tries to reparse it or update the visualization. This behavior has a big advantage. It allows us to update visual content dynamically and almost instantly across multiple screens. But it also introduces a major challenge. Because system is continuously parsing the file, even a very small mistake such as missing closing tag or an incorrect attribute or formatting error can prevent the entire file from being rendered correctly. So, in many cases, Google Earth does not clearly report these errors on the display. So, instead of seeing a clear error message, we often see a simple missing content, black screen, or outdated visuals that refuse to update. As a result, troubleshooting KML parsing issues becomes one of the most important skills for developers when working with Liquid Galaxy applications. Understanding how KML is structured, how it is parsed, and how a Liquid Galaxy loads these files is essential for building stable systems and quickly diagnosing visualization failures when they occur. Now that we understand why KML is important, let us look closely at what KML actually represents inside Liquid Galaxy system. KML is an XML based format file, which means that it is a structured markup language similar to HTML. Its main purpose is to allow developers to describe geographic features, camera positions, and visual elements in a structured and a readable way. In normal application, we usually deal with buttons, layouts, and widgets. In Liquid Galaxy, instead of UI components, we work with geographic and spatial elements. For example, when we place a marker on a city that is described as the KML place mark, when we move the camera to a new location, that movement is described using camera and look at tag. In Liquid Galaxy, KML is used for different purposes. We use it to place mark specific location. We use it to display project logos on screen overlays on individual rigs. We use it to show HTML based information balloons with interactive content. We can also use it to visualize paths, polygons, and 3D models. For example, to show routes, boundaries, buildings, or terrain features. And finally, KML is used to control advanced behavior such as tours and orbits. When camera automatically moves to a predefined path or rotates smoothly around a point of interest, uh, now, one very important design aspect of Liquid Galaxy is that application itself does not render any graphics directly. Unlike typical graphic engine, Liquid Galaxy does not draw shapes, textures, or animations by itself. Instead, it relies entirely on KML to instruct Google Earth what to display and how to display it. So, in practice, our application is not sending images or frames, it is only sending instructions. These instructions describe what should be shown, where should it be shown, and how the camera should move to show it. Because of this architecture, any issues that appear in visualization usually does not come with rendering code but instead originates from the KML on how it is written, how it is generated dynamically, or how it is loaded by the system. This is why something looks wrong on the screen or there are any visualization errors. The first thing we should always suspect is not the UI or the logic, but the KML itself. Its structure, its values, and the way it's been interpreted by Google Earth. Now let us move to one of the most important technical aspects of KML, its basic structure and why it is extremely sensitive to parsing errors. KML follows strict XML rules. This means that every tag must be opened and closed correctly, and every element must be nested inside the proper parent element. Unlike many programming languages, XML does not allow flexibility or assumptions. For example, if we forget to close a tag or if we close it in a wrong order, the entire document becomes invalid. Even very small issues can break the file. A small misplaced angle bracket, an incorrect indentation, or a missing namespace declaration can cause Google Earth to completely reject the file. And the important part is that Google Earth does not try to partially render the file. If the structure is invalid, it does not render the correct parts and ignore the wrong parts. Instead, it usually ignores the entire file. In Liquid Galaxy, this behavior often results in a very confusing situation. KML file exists on the system, but it's been completely returned to the disk. The controller believes that it is sent valid data, but on the screen, nothing appears at all. This is especially problematic because Google Earth may not display any explicit error messages. So, from developers' perspective, it looks like the system is not refreshing, or the controller is not working, or communication has failed. But in reality, only problem is that small structural mistake inside the KML file. Because of this, one of the most important debugging principles in Liquid Galaxy is whenever we face visualization error, first thing we should verify is the structural correctness of the KML before checking the logic, refreshing behavior, or slave targeting. We must first confirm that the file is well formed KML XML, has the correct namespaces, and follows the expected hierarchy. This step alone can eliminate a large percentage of parsing related failures. Now, let us understand how Liquid Galaxy actually loads and displays files internally, because this part explains a large number of real world bugs that developers face. Liquid Galaxy does not load KML files manually, instead, it continuously monitors specific files to decide whether it should be displayed, what content should be displayed on each screen. This means that Google Earth is not waiting for a command like open this file now. Instead, it keeps checking certain files again and again. And whenever these files change, it reparses them and updates the visualization. At the center of this mechanism is the file called kml.txt. This file acts as a central list that tells Google Earth which files it should load. So you can think of kml.txt as the main index file. It does not contain visualization instruction itself, but it contains references or paths to actual KML files that describe the content. In addition to the central file, Liquid Galaxy uses a slave-based architecture. Each screen or each rig has its own dedicated file, such as slave underscore number.kml. For example, slave underscore 1.kml, slave underscore 2.kml, slave underscore 3.kml, and so on. Each of these files are read independently by its corresponding Google Earth instance. This design allows different screens to display different content at the same time, which is one of the main strengths of Google Liquid Galaxy. However, this architecture also introduces very important class of errors. If a KML file is stored in the wrong directory or referenced incorrectly inside kml.txt or written in an unintended slave file, the system will simply not parse or display it. This confusing part is that this can happen even if the KML content itself is perfectly valid. So in this case, there is no syntax error, there is no structural problem, and there is no logical issue in the instructions. The only problem is that correct Google instance is not reading that file. This is why when debugging visualizations issues, we must always verify three things in this exact order. First is the KML file valid. Second, is the file stored in the correct directory and referenced correctly in kml.txt. Third, is the correct slave machine reading that file. Many parsing and rendering issues in Liquid Galaxy are not actually caused by syntax error, but by simply by incorrect file placements or wrong slave targeting. Now let us talk about one of the most frustrating and challenging problems in Liquid Galaxy development: KML not displaying and silent features. One of the biggest difficulties when troubleshooting KML parsing issues in Liquid Galaxy is the lack of visible error feedback. In many systems, when something goes wrong, we get an error message, a log, or an exception. But in Google Earth, this often doesn't is not the case. When Google Earth encounters an invalid or malformed KML file, it frequently fails silently. This means that instead of showing a clear error on the display, it simply shows nothing. The screen may remain blank, or they may continue showing old content, and there is no obvious indication that parsing issue has occurred. This creates a very confusing situation for developers. From the outside, it looks like the refresh mechanism is broken, or the controller is not sending data, or the system is frozen. But in reality, the only problem is the small mistake inside the KML file. When we open the file manually inside Google Earth Virtual Machine, the Google Earth often displays a parsing issue error pop-up. This pop-up explicitly tells us that file is an invalid KML structure. This is extremely helpful because it immediately confirms that issue lies in the file structure itself, not in the refreshing behavior, file placement, or screen targeting. In other words, the step allows us to distinguish between two very different categories of problems. First category is true parsing errors, where the KML file is syntaxically or structurally invalid. Second category is the system level issues, um, such as refresh displays, caching, or wrong slave targeting. By triggering this explicit error message through the virtual machine, we can quickly narrow down the root cause and avoid wasting time debugging unrelated components. This method is often the fastest way to confirm whether there is a visualization error caused by the KML itself or Liquid Galaxy loading mechanism. Now that we understand how silent features happen, next important question is how do we reliably identify parsing errors? A very effective troubleshooting way approach is to validate KML files outside the Liquid Galaxy environment. First step is to use online KML validators. These tools quickly check whether the file follows the correct XML syntax, whether all tags are properly closed, whether the namespace attribute is valid. Um, However, validation alone is not sufficient. The second and the more important step is to test the same file directly in Google Earth Pro on a local machine. This allows us to see how Google Earth itself interprets the file without any interference from the Google Earth Liquid Galaxy loading mechanism. Now, two very different outcomes are possible here. First case, the KML loads fails to load locally. When this happens, the issue is almost related to syntax errors, structural problems, or unsupported elements inside the file. For example, the file may contain invalid XML or missing namespace, or the KML features are not supported by the correct version of Google Earth. In this situation, there is no need to debug the Liquid Galaxy at all. The problem is entirely inside the KML file and it must be fixed before testing in multi-screen environment. The second case, the KML works perfectly when open locally in Google Earth Pro, but fails to display correctly on Liquid Galaxy. This is very important diagnostic signal. It tells us that KML file itself is valid and that the problem is not related to syntax or structure. Instead, the issue is more likely related to the file placement, loading order, refresh behavior, or slave targeting inside Liquid Galaxy environment. This separation is extremely powerful. By simply testing locally first, we can immediately divide the problem space into two clear categories. Now, let us move to a very common and a practical source of parsing problems dynamic KML generation from Flutter not working properly. In many Liquid Galaxy applications, KML files are not written manually, instead, they are generated dynamically using Flutter string templates. This approach is very powerful because it allows us to generate content on the fly, update camera position dynamically, and create interactive visualization based on user input. However, it introduces a new category of parsing issues. When we generate KML using a string template, very small formatting mistakes can easily corrupt the XML structure. For example, extra spaces at the beginning of XML declaration, unintended line breaks inside the tags, or incorrect variable interpolation can completely break the file. The most dangerous part is that these errors are often invisible in the source code. In Flutter, the string may look perfectly fine. The application compiles successfully and the file is written correctly to the disk. But at runtime, generated output may contain hidden white space, broken tags, or missing values that make XML invalid. Another important point here is that Flutter does not validate KML syntax. Flutter simply writes string to the file. It does not check whether the output is a valid XML, whether the namespace are correct, whether all tags are properly closed. So the responsibility of validation falls entirely on the developer. A very effective debugging technique in this situation is to directly inspect the generated file on the virtual machine. By using commands such as cat on the virtual machine, we can print the raw file contents exactly as Google Earth sees them. This allows us to detect invisible issues such as unintended white space, extra new lines before the XML declaration. In practice, many parsing errors that seem mysterious are actually caused by very small formatting mistakes in dynamic generated strings. So, whenever KML is generated programmatically, manual inspection of raw output becomes one of the essential debugging steps. Now let us look at screen targeting and slave specifying issues. In Liquid Galaxy, each screen reads its own KML files such as slave underscore 1 KML, slave underscore 2 KML, and so on. Because of this, even when the KML is valid and being parsed correctly, the content may appear on a different screen than intended. This is especially common when placing logos, balloon on the leftmost or the rightmost reg. If the slave index is calculated incorrectly, the content may be rendered on the wrong rig and or outside the visible area, which looks exactly like a rendering failure. The key point here is that this is not a parsing problem, but it is a purely a targeting problem. So when content seems to be missing, one of the first things to verify is whether the content slave uh, content is file is written on the correct slave or not, and whether the slave indices match the actual number of the rig in the system. Now let us look at the refresh behavior and the role of set refresh mechanism. Even when a KML file is written correctly and placed in the correct directory, it may not appear immediately on the screens. This happens because Google Earth catches previously loaded files, and the slave machine may not reload the file instantly after it changes. This often leads to developers to wrongly assume that there is a parsing error, when in reality the system is displaying outdated content. The set refresh mechanism solved this problem by forcing each slave machine to periodically reload its KML files, which set refresh enable updates propagate within the seconds across all screens without requiring restarts or manual reloads. So when content appears inconsistently or only after a reboot, first thing to check is not the syntax or but whether refresh behavior is correctly configured. Now let us look at KML complexity in orbits and tours. Orbits and tours are among the most fragile KML structures in Liquid Galaxy because they rely on GX extensions, camera definitions, and ordered action sequences. Unlike simple place markers or overlays, tours dependent on precise timing, uh, correct altitude modes, and properly structured playlists. A very small mistake, such as incorrect look at parameters, or a wrong altitude mode, or a broken sequence, can cause entire orbit to fall silently without any visual output on the screen. Because of this, the best practice is to always build orbit related KML incrementally. First, test the simple flight to view, then add rotation, and only at the end add timing and animation logic. This step-by-step approach makes debugging much more easier and avoids silent failures in complex camera movements. To conclude, troubleshooting camera parsing issues in Liquid Galaxy is mainly about understanding how the system actually works internally. Most visualization failures do not come from complex logic bugs. They usually come from small structural mistakes, incorrect file placement, wrong slave targeting, or outdated cache content. By validating KML early, testing files locally, building complex features incrementally, and completely configuring refresh behavior, developers can eliminate most parsing related problems very quickly. The key takeaway is that effective debugging in Liquid Galaxy is less about trial and error and more about having a clear mental model of how KML is loaded, refreshed, and interpreted by Google Earth. With this approach, we can build stable, reliable, and scalable visualization driven application on top of Liquid Galaxy. Thank you for watching. And I hope you learned something from this presentation.